Optimizing API performance is crucial to ensure smooth, fast, and scalable user experiences. In this video, we're going to dive into common performance bottlenecks that can slow down your APIs, strategies you can use to optimize their speed, and how key components like caching, API gateways, and load balancing can help you handle high traffic more efficiently. So let's start by talking about the common bottlenecks that might slow down your API performance in high traffic applications. One big issue is inefficient database queries. If your queries aren't optimized, they can really drag down the response times of your API. The solution here is pretty simple. Optimize your SQL queries, use proper indexes, and implement techniques like pagination or filtering to reduce the load of the data being pulled. Another thing you might run into is excessive network latency. If there's a lot of delay between the client and the server, it can cause noticeable slowdowns. To fix this, you can use content delivery networks, or CDNs, to strategically place your servers closer to your users to cut down that latency. Then there's overloaded server resources. If your server doesn't have enough CPU or RAM to handle all the incoming requests, it can either slow down or even crash. To solve that, you can scale your resources either vertically or by adding more power to your current server, or horizontally by adding more servers to share the load. And you can even set up auto-scaling automatically to adjust resources based on demand. Another bottleneck is synchronous processing. APIs that rely on waiting for a response from external services can get stuck in bottlenecks. The best solution here is to switch to asynchronous processing or use background tasks to handle long-running operations. Tools like RabbitMQ, Apache Kafka, Celery, and AWS Lambda are great for this. Now that we've gone over some of the common bottlenecks and how to fix them, let's talk about caching strategies, which can make a huge difference in improving your API performance. Caching is one of the most effective ways to boost your API performance, especially when handling high traffic. Let's first talk about the different caching strategies you can use, and then we'll discuss how caching really makes a difference in improving your API's performance. First up, in-memory caching. Think of something like Redis or Memcached. This is where you store frequently accessed data, like user sessions or commonly queried information, in memory for quick retrieval. This means that the data doesn't have to be fetched from slower sources, speeding up response time significantly. Then we have HTTP caching. This involves using cache control headers, or E-tags, to leverage the browser or reverse proxy caches. This reduces the load on your API server by serving cached responses for requests that are identical. Another important strategy is database query caching. This means caching the results of expensive database queries so they don't need to be repeated every time the same request is made. It cuts down on unnecessary database hits. Content delivery networks are also incredibly helpful. These CDNs cache static content, like images or other assets, at edge locations closer to the user. This helps to cut down on load times and saves your server from unnecessary work. Lastly, there's application-level caching. This involves adding cache layers within your application to store intermediate results from things like complex calculations or aggregations that are computationally expensive to perform. Now let's talk about how all this caching can really improve your API performance. Caching reduces latency. Instead of fetching data from slower sources like databases and external services, you're getting that data from the cache. This results in faster response times for users. It also decreases server load. By serving up cache data, your API server isn't constantly being bombarded with the same request over and over. This frees up server resources for other tasks. Caching also scales better as your traffic grows. Since you're reducing expensive database queries or computations, your system can handle more requests without slowing down. And finally, it improves user experience because with faster response times, your users will be much happier, especially in high traffic environments where every millisecond counts. So, now that we've covered caching, you might be wondering, what about API gateways and load balancing? These are just as important when it comes to managing high traffic applications and ensuring reliability. API gateways act as a middle layer between your clients and your backend services. Their job is to manage incoming requests and route them efficiently to the right place. Some great tools to help with this are Amazon API Gateway, which integrates well with other services, Kong, which is open source and very flexible, and NGINX, which is known for performance and scalability. The benefits of using an API gateway are huge. For example, it can help with centralized authentication, rate limiting, and request logging. It also simplifies integration by combining multiple services into one endpoint and offloads unnecessary work from your backend. Next, we have load balancing. A load balancer is responsible for distributing incoming traffic across multiple servers so no single server gets overwhelmed. Some popular load balancing tools include Nginx, which is great for performance and routing, HA Proxy, which is open source and known for reliability, AWS ELB, which is fully managed, and Traffic, which is perfect for microservices. The key benefits of load balancing are improved scalability, fault tolerance, and session persistence. It helps ensure that if one server goes down, the traffic will be routed to healthy servers. Plus, it keeps user sessions consistent if needed. Together, caching, API gateways, and load balancing form the backbone of a high-performing API system that can handle large volumes of traffic without sacrificing speed or reliability. Optimizing API performance for high-traffic applications requires a multifaceted approach. By addressing bottlenecks, implementing effective caching strategies, and using API gateways and load balancing, you can ensure your API scales efficiently as traffic grows. At Keyhole Software, we specialize in building scalable, high-performance APIs that are tailored to your specific business needs. We can help you identify and resolve performance bottlenecks, implement seamless caching, and optimize load balancing so your API can scale effortlessly. Whether you're looking to improve response times, reduce downtime, or enhance user experience, Keyhole is here to provide hands-on experience to future-proof your API infrastructure. Reach out to us today to optimize your API and take your application's performance to the next level.